and then the time series. This is a simple plot of the time series. What is the difference between time series and the regular data? This is something which you have to understand, although you may not be dealing with time series, we may not be dealing here. What is the difference between time series and the data which we use, which we plotted here? This is frequency, but a simple, what is the difference between time series? So, suppose I collect, let us say, the efficacy of a medicine, a drug molecule, or a drug molecule or a vaccine. Is that a time series or is that a regular? What is the difference? This is very important for later analysis. What is a time series? So, you all know regression, y equals to mx. So, is x and y, is it a time series data or what kind of data is it? Dependent, independent, okay. Now, so y equals to mx, you say y and dependent variable, x is independent variable, input, output or dependent, independent. Now, is it steady state data or dynamic data? Steady state or dynamic? What do I mean by steady state and what do I mean by dynamic? What changes over time? Output changes over time based on the input. So, in y equals to mx, if x changes, y will not change. So, is it steady state or dynamic? Dynamic. So, 4 equals to m times 2, okay. 6 equals to, or 4 equals to m times 2, right. So, let us say m equals to 2, so if you change x, y is changing. Is that all dynamic? Is that what you mean by dynamic? So, what do you mean by steady state? Whatever you give, y equals to mx is, that output will not change at all. Whatever you give, the output is fixed, is it? V equals to I times R, right. I have an R, okay. I have a circuit which has only R. I have a circuit which has RC. Can you tell me what is steady state? What is, is there a difference between these two systems? Can you see? What is the difference between these two systems? There is no time relationship. If V changes, I will change, R is fixed, okay. Now, when it comes to a RC circuit, what happens? There also there is a steady state if you keep the input for a longer time. If you keep input for a constant for a longer time, there is a evolution, and after the evolution it reaches the, there is a steady state transient followed by a steady state if you would have held the input constant. What is the difference between two? If you look at the steady state, both have steady state. What is unique about or different about the RC circuit? The transience. What is that? The system is evolving as a function of a dependent variable, independent variable, which in this case is time. You understand? So, take an image, sequence, you are taking an image, right. Is this image steady state data or time domain data, time series data? Give you an image, what is of interest to an image? Let us talk as engineers, not as humanities people. What is of interest to us? Pixel intensity, good engineer. So, pixel intensity varies as a function of what? Position, x, y. So, it is actually a time series where time is not the independent variable, x and y are the independent variable. In a video, what happens? 3 independent variables. So, what is, how do you mathematically represent a video? What is, so image, how do you represent? Mathematically, if I want to represent image, how do you do? Matrix. X is position, y position, intensity value. It is a matrix, it is a time series. What about your what I call your video? Jacobian matrix. You all know what is tensor flow, you have heard of this? That is the reason why it is called tensor flow, okay, because you can process videos, and video is a mathematically a tensor, because it is taking up of matrices. You can stack up it and you can unstack in multiple ways. Okay, you can look along xy, you can look along yz, you can look along xz. Okay, there are 3 ways to unfold a tensor, but tensor is nothing but a stacking up of matrices. So that is also a time series. Now tell me the difference between time series and a steady state in biomedical engineering, in biomed. Give me some variables which are time series. ECG, EEG, EMG, right? MRI, X-ray, these are images, right? And videos, today we have MRI, one image or what? No. CT scans, only one image? No. Video. So these are fMRI, put together all of them, these are time series data. These are analyzed and modeled very differently. Why it has to be analyzed and modeled very differently? You need to know the difference, because when you analyze, you need to know what you are dealing with. These are things people will not tell you, I mean you are supposed to know. So what is, how, why is it important to deal with these things separately, time series separately, unlike your steady state data? Give me an example of a steady state data. Now becomes difficult. Give me an example of a steady state data in biomedical domain. Height will not change as a function of time. If it has changed, we will all be happy, right? Weight, height will not change as a function of time, right, for most of us. It depends on, right, once you get saturated, hardly you notice, right, after a certain age, hardly you notice. Weight is slightly dynamic depending upon our, not slightly, heavily dynamic in a sense, but you look at blood parameters, the way it is measured, you average it out, you do not measure instantaneous, you average it out multiple times, and therefore blood parameters usually you do not say it is dynamic. See, they will say blood sugar is highly dynamic, right, but if I say that not, and that is also the reason why any of our measurements, if you have noticed, when you take blood samples as well, all the observations, they will not go by a single number. Why? Will you say, they will say, always say, even if you take sugar, what do they say? Less than 120. 110 to 120 is pre-diabetic, they will give name labels, but they have a range from 80 to 120. Why? To allow for dynamic nature of the process. In body, hardly there is anything steady state. People earlier thought brain is static, but figured out brain is the most dynamic. It has plasticity. I am sure you would have by now aware, right? Earlier people thought brain does not evolve, but that is a big mistake. Brain's plasticity is too large. I mean, it can adapt very heavily, right? Heart is not dynamic. Heart is it heart not dynamic? Extremely dynamic. So the entire body is actually a dynamic system, right? You would hardly think about something which is static, okay, right? It is usually a function of time component evolves, right? We only do steady state, we can model steady state aspects. See, even in a dynamic system, we have steady states. If I hold the input long enough, you will reach a certain output, and you give. So there are two things when you deal with biomedical data, okay. When we are talking about time series, the reason why I stopped here is we are dealing with two things when we are talking about time, biomedical data. One, the dynamic nature of the system. That means the relationship, when you want to truly build, you can build two models, dynamic, static, or a combination. When you are looking at only the steady state relationship, or when you are looking at the dynamic nature. See, even if you look at brain waves, right, or brain waves, if you look at brain waves, I can only simply look at the power in each frequency range. That is one way. What is that? Suppose I measure here, your EEG, and then say brain frequency of beta wave, theta wave, alpha wave is like this. That is one way to look at it. I can, this itself is a time series. Now I can look across electrodes, that becomes even more complicated, multiple time series, right. So the body is so dynamic that everywhere whatever you measure will be a time series data, you have to keep in mind. Even blood samples, whatever you measure will be a time series data, okay. Then second, our human body is not only dynamic, it also responds to too many inputs that you may not be even aware of. So the output is going to be random, there is always going to be randomness in your output. So two things we do to simplify are the following, okay. We hold the input constant for long enough duration. So what happens? So when do they take a blood sugar reading? There is something called procedure for every, there is a procedure or protocol to be followed for every diagnosis. Suppose if they ask you if they are testing for blood sugar, what do they do? Fasting, right, and they have the range. Why do they give a range? For accommodating what? Dynamic nature, for accommodating the randomness. For accommodating the randomness, there is always a range, okay. And for accommodating the dynamics, what do they do? In testing of blood sugar, what do they do? We will take a simple example, only then you will know what it means. In testing of blood sugar, dynamic nature, so you have to wonder why this range is given, because it is of accommodate the randomness among people, okay. The next step is, how do you have to accommodate the dynamic? Are we doing something dynamic here? I am only looking for a number, range. So how do I accommodate the dynamic nature of the body? Procedure, fasting, your input is 0. How long after fasting you take the blood sugar? Minimum 8 hours, minimum. Why? Dynamics settle down, you do not feed in for 0th hour up to 8 hours and then you take fasting. And why fasting blood sugar? Why fasting? You are not allowed to eat anything, and this fasting blood sugar will also have problems. I will tell you what you will unravel one by one, we will learn. So you sleep at 10, you get up at 6, 7 o'clock you test, that is one protocol, that is one number, that is a decent number what you get. Why? Because there is a dawn phenomena. See, our body is never static. You sleep does not mean the body sleeps. The body is what I call the body mechanism sleep. When you sleep, pituitary becomes active, pituitary heals the body, and at 2 o'clock, suppose you measure blood sugar at 3 o'clock in the night, you will be surprised, it will be very high. You know why? 3 o'clock, you are all biomedical engineers, right? 3 o'clock if you measure your blood sugar, that is when it will be high, maybe even the peak the whole day compared to what you have in the whole day. You know why? Body is getting ready to wake you up. So when the body is getting you ready to wake you up, the brain needs what? Sugar, glucose. And where is the glucose from? Where is it stored? Glucose is from where? Liver. So liver starts pumping glucose, that is called dawn effect, okay. So between 2 to 4, liver starts gets activated, pumps in enough blood glucose, okay. And that is why you do not measure at 4 o'clock, you measure after 8 hours, after the dawn effect is settled, okay. Ideally if you do not eat for 8 hours, why should it be 110? It should be lower, right? It should be lower region, no, because the dawn effect will be there, and if your cells, islet cells or pancreatic cells are good enough, then the excess, the insulin will control them, and then all the excess, the glucose will be absorbed by the cells and get ready for the day. That is when you reach an 80 to 120 level. If it is 150, 160, it means your insulin is there, or insulin may not be there, that is a different story, confounded effect, but your insulin is not doing the job. You have a protocol. Now imagine if I sleep at 2 o'clock, what happens? I sleep at 2 or 3 and then I take a test at 10. Is it the same way? Will the dawn effect be there at all? Then is 80 to 110 a good range? Do not know. You see, the procedure plays a major role, right? That is why the procedure is prescribed to settle down the dynamic, known dynamic nature of the body, and this range is given so that accommodate randomness. And if you talk about let us say a procedure at 2 hours later, your blood glucose should be below 140, that is postprandial, right? Why 2 hours? Dynamics. It is usual that after 1 hour, if you have a heavy meal, it will reach up to 180, and then it should come back to 140, below 140 after 2 hours. That is because of the half life, or the how the islets respond to insulin, how for a normal body, and to accommodate the randomness they have given up to 140, right. So every measurement what you take in from human body is dynamic, and it is a time series. The only thing way to do away with this is you are not looking at a dynamic data. So am I interested in how my blood sugar goes from all the way from let us say from night 110 or 120 all the way again to 130? I may not be. That means what? You have to dynamically measure blood glucose. That will have a lot of activities in the body which will also be confounding my values, which will influence my values, and I may not be even knowing it. So what do? I voluntarily look for only steady state by holding what? Holding the inputs constant, giving enough time. That is what a procedure is. You understand? So why is it important to us? As a biostatistician, you have to think, what kind of data am I dealing with? Is it a dynamic data? Is it static data? Is the procedure followed correctly? Not followed. That it becomes an outlier to you. If the procedure is not followed, it definitely becomes a outlier. It is of no use to us. Why? There is dynamic effect, right. People, if they say, I just ate one idli and went, test is of no value. They will be taking you test knowing that it is of no value, because you paid for it, but it is of no value, right. That is the same case with most of it. The ECG, EEG are dealt very differently. How do I do ECG, EEG, what am I? So as let us say as a student, what will you look at? ECG, EEG, ECG, let us take ECG, what do you look at? PQRS, the how do we do? You look at only one thing and do it? Is the machine, whatever gives, today the machine will give you numbers, right. Do you think the machine is going to compute one peak and give you a value between 2 peaks? What does the machine do? Imagine that if we go to ECG, we take an ECG. Have you seen the ECG graphomer? What does it tell you? It will give you the interheart, and then it will say normal, or sometimes if it is a problem, it will say otherwise normal. Okay, you will have a class and they say otherwise normal, but you have this, right, time durations, etc. How does it calculate? Just using one peak? The graph will show you representative PQRS. Internally, you would have given enough time to average out. And what are we saying? The average heartbeat should be in this range. Look at again, very clear. 2 things. Average. Why? To accommodate for dynamic nature. okay. It also some way accommodates for randomness. Then the range again accommodates for randomness, the difference in each one of our bodies, okay. So that is why it is, that is how it is, clear. So somebody see, and how important this range is. Somebody says 80 to 120, suppose somebody has 130, today they are named diabetic. Not just that, your insurance policy cost goes high immediately and you are supposed to take medication. What is the importance of this range? You understand, it plays a big role in human life, a small variation. So now is this right, 80 to 120 right for everybody across Asia, across countries, for our kind of food, for our kind of environment, and for the western world, is it important? Not really, may not be at all, okay. So one has to take these numbers with a pinch of salt, and that is where today people are moving towards modeling dynamic. Even for blood glucose, today there are patches which monitor continuously, so that you have a pattern of yours. And then today nobody relies just on fasting blood sugar or postprandial. What do? HbA1c 3 months, averaging it out, so that you have a 3-month range, right. So these are, as statisticians, we have to look at what is the quality of data we get, okay, why bio is observed in this fashion, okay. With that I will stop for today.